Inside your neck, a tiny gland captures iodide and transforms it into hormones that ignite the body's metabolic flame. From brain to heart, liver to muscle, thyroid hormones carry metabolic signals that help power the entire body. The story begins with iodine, a rare trace element the body cannot make but must obtain from food. After absorption, iodine circulates mainly as iodide, a tiny negatively charged ion called I-.
The thyroid is built from follicles, tiny circular factories where iodide becomes thyroid hormone. The follicular cell has two working surfaces, a blood-facing side and a colloid-facing side. On the blood-facing surface sits the sodium iodide symporter, or NIS, the thyroid's iodide intake gate. NIS does not directly burn ATP. It uses the inward rush of sodium to pull iodide into the cell. The sodium iodide symporter harnesses the sodium gradient to actively transport iodide into the cell. This process is essential for thyroid hormone synthesis and overall metabolic health. The real ATP-consuming engine is the sodium-potassium ATPase pump. This pump keeps sodium low inside the cell, creating the gradient that allows NIS to keep working. Mitochondria supply the ATP that supports ion pumping, protein synthesis, and hormone production. Through this energy-supported system, the thyroid concentrates iodide far above blood levels.
Once inside the cell, iodide moves toward the apical surface, where hormone synthesis will begin.
At the apical side, iodide enters the follicular lumen, the biochemical workshop of thyroid hormone synthesis. Inside the colloid waits thyroglobulin, a massive protein scaffold carrying tyrosine building sites. Thyroid peroxidase, or TPO, uses hydrogen peroxide to activate iodide for hormone assembly. When iodine is attached to tyrosine on thyroglobulin, the process is called organification. One iodine attached to tyrosine forms monoiodotyrosine, or MIT. When two iodine atoms attach to tyrosine, the product is diiodotyrosine, or DIT. When MIT couples with DIT, the thyroid forms T3, the more biologically active thyroid hormone. When two DIT molecules couple, the thyroid forms T4, the major hormone released into circulation. The thyroid stores these hormones attached to thyroglobulin, creating a unique extracellular hormone reservoir. When thyroid hormone demand rises, the pituitary sends thyroid-stimulating hormone, or TSH. TSH tells the thyroid to increase iodide uptake, hormone synthesis, and hormone release. The pituitary gland releases TSH, which travels through the bloodstream to stimulate the thyroid gland. This pathway is a key part of the endocrine system, regulating metabolism and energy. Lysosomes digest thyroglobulin, freeing T3 and T4 for release into the bloodstream. Now the thyroid's chemical messages enter circulation and travel to nearly every tissue. In many tissues, T4 is converted into T3, the stronger signal at thyroid hormone receptors. T3 enters the nucleus and changes gene expression, tuning the body's metabolic machinery.
Thyroid hormones increase oxygen use, heat production, and energy turnover.
The effects reach the heart, brain, liver, muscle, fat tissue, and developing nervous system. Some environmental anions, especially perchlorate, nitrate, and thiocyanate, can interfere with iodide uptake at NIS. Other endocrine disruptors, such as BPA and phthalates, may affect thyroid signaling through broader mechanisms. When thyroid hormone output falls, metabolism may slow, reducing heat production and energy turnover. The thyroid and GLP-1 systems both influence metabolic health, but GLP-1 is not a proven central regulator of iodide uptake. From one trace element, the thyroid builds the signals that tune the body's metabolic flame.
Knowledge has the power to transform lives. At SKM Edutech, we bring education to life through powerful visuals, engaging storytelling, and innovative learning experiences. Subscribe today and become part of a community where curiosity meets excellence.